Hi everyone, it is a pleasure to be here and share with you the story of how we created the perfect dressing room for Yahaha. First of all, let's explain why we use Flutter to develop Yahaha. Our idea, Yahaha, is not just to explore in a virtual space or play a game. We envision Yahaha as a social platform that connects users and fosters friendship through shared interests and group activities. To execute this vision, creating an intuitive and user-friendly interface is crucial. There are different ways to build this UI generally. The first is use native components or advanced frameworks that use native components, like React Native. The second is use Unity tags such as UGUI or UI elements. The third is use another UI engine like Flutter. I made this comparison table to show pros and cons in the above three ways. There are also three main points that we have to consider: the dev efficiency, the consistency, and the performance. In terms of dev efficiency, with Flutter, we could hot reload during coding. Once the code is modified, we perform a hot reloading. Then we can immediately see the changes without recompiling and installing it. This can greatly speed up our development, finding bugs and fixing them. At the same time, Dart is a new language, which is similar to TypeScript. It takes only a few days to learn it. After several years of accumulation, the community already has a lot of convenient plugins, which can be used to solve some common problems. About the performance, we all know native components drawn by system are the best. Flutter's performance is close to the native ones. Besides, in recent years, the hardware of mobile phones has improved rapidly. The differences in performance between the above three ways is even harder to detect. Speaking of consistency, this problem only exists when we use native components. The components provided by iOS and Android are not so consistent. There are differences from the overall layout to the properties of each component. Just like a button, its clicker effect, shadows, borders, and touch feedback. These attributes require time and effort to adjust to ensure that users who use an iPhone or an Android phone have the same experience. Unfortunately, not just between iOS and Android. There are many reasons why they behave differently. The first is the OS version, like iOS 13 and iOS 15. Second, Android have many manufacturers, and their customized OS, like Samsung and Xiaomi. This reminds me a few years ago, developers needed to do browser capability work. So using this direct UI styled technology is why Flutter is chosen. After discussing the basics of Flutter, let's dive into the exciting possibilities of combining these technologies and explore the steps involved in creating impressive cross-platform experience. Unity has introduced a new feature known as Unity as a library. This feature allows developers to render Unity without monopolizing the screen. The 3D scene can now be rendered as a standalone widget, which makes it easy to display the 3D scene anywhere we want. This is an exciting development that opens up a new world of possibilities, especially for applications that require a seamless integration between Unity and other software. For instance, designers can now use Unity as a 3D visualization tool that can be easily embedded in their design workflow. Additionally, game developers can use Unity as a game engine that can be integrated into a larger system that requires real-time 3D rendering. With Unity as a library, developers can now have greater flexibility and control over how they use Unity in their projects. Flutter offers a feature called Platform View. Platform View allows developers to seamlessly integrate native platform components, such as a game engine, into their Flutter application. This not only enhances the overall user experience, but also allows for greater flexibility and creative freedom in creating cross-platform applications. At the same time, Flutter manages the hierarchy of these widgets, so touch events could be dispatched correctly. The result is a more cohesive and user-friendly application that is easier to maintain and update over time. By leveraging these powerful features, our team was able to create an impressive dressing room. The process involved carefully passing the app state to Unity, dynamically laying out the interface, and then seamlessly presenting it within the Flutter application. This approach not only optimizes performance and reduces loading times, but also ensures that the dressing room is highly responsive and easy to navigate. Let's watch a small demo of how this works. You can see the bottom layer is rendered by Unity, and the top layer is rendered by Flutter. The next question is how to make it possible that Flutter and Unity communicate with each other. We need to establish a two-way communication channel that enables the transfer of dress-up related data. This involves implementing a custom API that allows Flutter to pass the dress-up information to Unity and vice versa, so that the two platforms can stay in sync with each other. As such, not only does Unity need to receive the dress-up information from Flutter, but it also needs to send back the updated dress-up status to Flutter. So, the front-end experience remains consistent and cohesive. One solution is to use the send message function provided by UAAL. We could wrap it and expose it to Flutter. As you can see, the function takes three parameters. The first is the game object name. The second is the name of the monobehavior script function. This function should be associated with this game object. The third is the string data. We can create a dummy object that does nothing but receive messages sent by the UI. However, the restriction is that the message data can only be string type. If we want to send something complicated, we must bundle it and do some serialization. At the same time, after trying several times, we found that it requires that the string should be null terminated, which means that sending an image data directly is not possible. We should convert it to be a hex string or B64 encoded string. This would take a lot of time when the message is large. For instance, a picture data would be hundreds of kilobytes. Unity processes this message as often as it refreshes. In general, we can only send 60 messages per second to Unity. So, we eventually abandoned this approach. We decided to implement this communication channel ourselves from the scratch. First, in order to avoid inconsistency in the parameters of handwritten code, we implemented a code generator and drafted a protocol between C#, Dart, and C. This protocol specifies type matching and the function calling style in these languages. Then, the code generator would generate the function bindings for each language. After generating function bindings, we utilized the multitude of functions provided by the C library to achieve the concatenation of data package, distribution, message notification, and other essential features for our communication channel. Through meticulous design and implementation, we ensure that each step in the communication process was carried out efficiently and reliably, enabling smooth communication between the different languages and the platforms involved. To illustrate further, let's take a deeper look at the process of generating function bindings for avatar put-on set. To begin with, we wrote the necessary stop code for code generation, which is essentially a non-existent programming language that serves as a blueprint for generating code in other languages. From the stop code, we are able to generate the dot bindings and the C# binding, which would serve as the foundation for the implementation of the avatar put-on set function. Next up, our expert avatar team took over the rule and began implementing the logic for this function. And when the user taps on the screen on an avatar set, it would trigger the dot binding function, which would then proceed to patch the invocation up and send it through the pipe. Upon receiving the patched invocation, the C# and the listener would intercept it and proceed to unpack it. From there, it would conduct the real job that was implemented previously, allowing for a seamless transition between the different languages and the platforms involved in this process. Through the meticulous implementation process, we are able to achieve a smooth and reliable communication channel for avatar put-on set, paving the way for even further advances in function binding generation. The advantage of this is that we don't have to align with Unity's refresh rate. If we want to do something to change the 3D scene resources, we can repost the message to the Unity main thread. It is as efficient as using send message to game object. Finally, let's see a video that will showcase the inside of the dressing room and give us a glimpse into its feature and layout. That's all. Thank you.